In general, it is good practice to ground both AC and DC circuits in a control panel, even if they are isolated from each other. Grounding provides a low impedance path for fault currents and prevents dangerous voltages from developing. For the AC circuit, connect the G terminal of the power supply to the grounding terminal of the control panel. Ground the neutral terminal if it is not already grounded. For the 24 volts DC circuit, connect the V terminal of the power supply to the grounding terminal of the control panel. The plus V terminal is not typically grounded. Grounding the AC circuit protects against shock hazards and provides a reference potential for electrical devices. It also helps reduce electrical noise and interference. Grounding the V terminal establishes a common reference point for all DC devices in the panel. This minimizes voltage fluctuations and helps ensure proper operation. The V terminal is typically grounded at the PLC or other DC source to prevent voltage spikes. There are some exceptions where it may not be necessary to ground the 24 volts DC circuit. Firstly, if the circuit is isolated from all other circuits and does not have any exposed terminals, and secondly, if the circuit is used for a specific purpose where grounding is not required. It is recommended to ground both the AC and 24 volts DC circuits. This will provide the best protection against electrical hazards and ensure proper operation of all components in the control panel. The grounding of electrical systems serves several critical purposes, primarily centered around safety and functionality. Grounding provides a low impedance path for fault currents, enabling protective devices like circuit breakers or fuses to quickly interrupt the circuit and prevent electrical shock or fire hazards. Without proper grounding, fault currents could travel through unintended paths, such as a person touching a faulty appliance, leading to severe or fatal electric shock. In AC circuits, grounding establishes a reference potential, typically 0 volts, which stabilizes voltage levels and prevents the buildup of static electricity. This reference point helps reduce electrical noise and interference, ensuring the reliable operation of electronic equipment. The grounded neutral conductor in an AC system carries any imbalance in current between the hot conductors, preventing voltage fluctuations and maintaining a stable power supply. Grounding also mitigates the effects of lightning strikes and voltage surges by providing a path for these high-energy events to dissipate safely into the earth, protecting equipment and personnel. In DC circuits, grounding the negative terminal creates a common reference point for all DC devices in the system, minimizing voltage fluctuations and ensuring proper operation of electronic components. Grounding prevents the buildup of static charge, which can damage sensitive electronic components and cause erratic system behavior. In control panels that incorporate both AC and DC circuits, grounding both systems ensures comprehensive protection against electrical hazards and promotes the reliable operation of all components. It's crucial to adhere to relevant electrical codes and standards, such as the National Electrical Code, NEC, to ensure proper grounding techniques and practices. Proper grounding requires the use of appropriate grounding conductors, bonding techniques, and grounding electrodes such as ground rods or grounding plates to create a low impedance connection to the earth. Regular inspection and testing of grounding systems are essential to verify their effectiveness and ensure continued protection against electrical hazards. When dealing with control panels, it's imperative to understand the specific requirements and recommendations for grounding both AC and DC circuits. This understanding helps ensure the safety of personnel and the reliable operation of the equipment within the panel. Firstly, let's discuss the AC circuit. The ground terminal, often labeled as G, GND, or with the ground symbol on the AC power supply, should be connected to the grounding terminal of the control panel. This connection provides a direct path to ground for any fault currents that may occur in the AC circuit. If the neutral terminal of the AC power supply is not already grounded at the service entrance, it should also be grounded at the control panel. This ensures that the neutral conductor is at or near ground potential, reducing the risk of voltage fluctuations and providing a stable reference point for the AC circuit. The grounding conductor used for the AC circuit should be sized appropriately based on the size of the circuit conductors, in accordance with the NEC Table 250.122 or other relevant electrical codes. All metal enclosures, conduit, and other conductive parts of the AC circuit should be bonded together and connected to the grounding terminal of the control panel. This bonding creates a low impedance path for fault currents, ensuring that protective devices will operate quickly and effectively. Secondly, let's examine the 24 volts DC circuit. The negative V terminal of the DC power supply should be connected to the grounding terminal of the control panel. This connection establishes a common reference point for all DC devices in the panel, minimizing voltage fluctuations and ensuring proper operation of electronic components. The positive plus V terminal of the DC power supply is typically not grounded, as grounding the negative terminal provides the necessary reference point and protection against voltage spikes. The grounding conductor used for the DC circuit should be sized appropriately based on the size of the circuit conductors, in accordance with the NEC or other relevant electrical codes. All metal enclosures, DIN rails, and other conductive parts of the DC circuit should be bonded together and connected to the grounding terminal of the control panel. This bonding ensures that all conductive parts are at the same potential, reducing the risk of electrical noise and interference. The rationale for grounding both the AC and DC circuits lies in the enhanced safety and improved performance of the control panel. Grounding the AC circuit protects against shock hazards by providing a low impedance path for fault currents, allowing protective devices to quickly interrupt the circuit and prevent electrical shock. Grounding the AC circuit also reduces electrical noise and interference, ensuring the reliable operation of electronic equipment. A stable reference potential is established, which is crucial for sensitive electronic devices. Grounding the DC circuit establishes a common reference point for all DC devices in the panel, minimizing voltage fluctuations and ensuring proper operation of electronic components. This reference point helps prevent voltage spikes and other transient voltage events that can damage sensitive electronic components. By grounding both the AC and DC circuits, the control panel is better protected against electrical hazards, and the performance of all components is optimized. There are some exceptions where it may not be necessary to ground the 24 volts DC circuit. Firstly, if the circuit is isolated from all other circuits and does not have any exposed terminals, grounding may not be required. In this case, the circuit is considered a separately derived system and may not need to be grounded, as long as it meets certain requirements outlined in the NEC. Secondly, if the circuit is used for a specific purpose where grounding is not required, such as in some intrinsically safe circuits, grounding may be omitted. Intrinsically safe circuits are designed to limit the amount of energy available in the circuit, preventing ignition in hazardous locations. However, it's important to note that these exceptions are rare, and it is generally recommended to ground both the AC and DC circuits in a control panel for maximum safety and performance. For most applications, it is recommended to ground both the AC and 24 volts DC circuits. This will provide the best protection against electrical hazards and ensure proper operation of all components in the control panel. Grounding both circuits ensures a low impedance path for fault currents, minimizing the risk of electrical shock and equipment damage. Grounding also helps reduce electrical noise and interference, improving the reliability and performance of the control panel. In addition to grounding the AC and DC circuits, it's also important to properly bond all metal enclosures, conduit, and other conductive parts of the control panel together. Bonding creates a low impedance path for fault currents, ensuring that protective devices will operate quickly and effectively. Bonding also helps reduce electrical noise and interference, improving the overall performance of the control panel. To ensure proper grounding and bonding, it's essential to follow all applicable electrical codes and standards, such as the NEC. The NEC provides detailed requirements for grounding and bonding, including conductor sizing, grounding electrode requirements, and bonding techniques. It's also important to consult with a qualified electrical engineer or electrician to ensure that the grounding and bonding system is properly designed and installed. Proper grounding and bonding are critical for the safety and performance of any control panel. By following the recommendations outlined above and adhering to all applicable electrical codes and standards, the risk of electrical hazards can be minimized and the reliability of the control panel can be ensured. Grounding and bonding are fundamental aspects of electrical safety and should never be overlooked. Proper grounding and bonding not only protect personnel from electrical shock but also protect equipment from damage due to voltage surges and other electrical disturbances. The grounding electrode system, which typically consists of ground rods, ground plates, or a combination of both, should be installed in accordance with the NEC. The grounding electrode system provides a low-impedance connection to the earth, allowing fault currents to dissipate safely into the ground. The grounding electrode conductor, which connects the grounding electrode system to the grounding terminal of the control panel, should be sized appropriately based on the size of the service entrance conductors, in accordance with the NEC. The grounding electrode conductor should be installed in a protected manner to prevent damage or corrosion. Regular inspection and testing of the grounding and bonding system are essential to verify its effectiveness and ensure continued protection against electrical hazards. Grounding impedance testing can be performed to measure the impedance of the grounding path, ensuring that it is within acceptable limits. Continuity testing can be performed to verify that all metal enclosures, conduit, and other conductive parts are properly bonded together. Visual inspection can be performed to check for any signs of damage or corrosion to the grounding and bonding conductors and connections. Any issues identified during inspection or testing should be promptly addressed to maintain the integrity of the grounding and bonding system. In conclusion, grounding both the AC and DC circuits in a control panel is generally recommended for safety and optimal performance. Grounding provides a low impedance path for fault currents, protects against shock hazards, reduces electrical noise and interference, and ensures proper operation of electronic components. By following the recommendations outlined above and adhering to all applicable electrical codes and standards, the risk of electrical hazards can be minimized and the reliability of the control panel can be ensured. Remember to consult with a qualified electrical engineer or electrician for any specific questions or concerns regarding grounding and bonding.